My name is Jill Hayes, and I'm going to demonstrate how to solve the scenario above. To perform the one sample z-test for this scenario, I will use Excel rather than SPSS. The reason why I do not use SPSS is because it does not have built-in function for a one sample z-test. This is due to the fact that in practice, the population standard deviation is usually not known when one is testing for the population mean. When the population mean is not known, you use a one sample t-test instead, and this particular test is available in SPSS. Excel also does not have a pre-programmed one sample z-test function. However, I can perform the required calculations for the one sample z-test using existing Excel formulas and functions. I will utilize this approach to perform my one sample z-test in Excel. I already completed steps 1 and 2 in my introduction and my example by stating the null and alternative hypothesis, as well as the significance level of 0.05 for this left tail test. As you recall, step 3 involves the calculation of the z-test statistic. One of the inputs of the z-test is the sample mean. If we input the 36 sample observations into Excel, we can compute the sample mean using the average function. In the Excel sheet, I have inputted the 36 sample IQ scores that you saw on the introductory table. Here are the 36 IQ scores. They are listed in a single column to make the scores easier to use in various Excel functions and formulas. I will calculate the simple mean by using the average function. First, I place my cursor in cell E1 to create an average function into that cell to compute the average. Here's cell E1, and what I'm going to do is compute the average by typing in equals average, open parentheses. Then what I do is I highlight all of the numbers for the IQ scores, close parentheses, and equals. Then what I want to do is I want to go to C1, just so it's next to each other. This is where I'm going to create a title for the average number, or what we call the sample mean. So I'll put in, sample mean. As you can see, the mean IQ for this sample of children is 98.72. As we saw in the introduction to this problem, the population mean that we are testing under the null hypothesis is 100. Now I'm going to enter that number into the Excel spreadsheet. So I'll go to cell E3. I'm going to type in the number 100. Now I'm going to go to cell C3 and give it a title. So we'll call it population mean, and it's mu sub 0. But because of the time constraints, we'll just consider it as population mean. But you should know it's mu sub 0. Other items that we need to use in the calculation of the z-test statistic is the population standard deviation of 16 and the sample size of 36. I will input both of these figures into the Excel spreadsheet so we can use them in calculations. What we're going to do is go to cell E5 and what I'll do is place the number 16 to represent the population standard deviation, and in cell C3 5, I'm going to give that a title. And we'll call that population standard deviation. And typically you would have this sigma sign there, but again, for time's sake, we'll just keep it at this. What you're going to want to do is notice here that some of the words are cut off. All you're going to do is push it over so we can see the whole title, the whole exact title. All right. Now what I'm going to do is go to cell E8. So here's E8. And I'm going to write the sample size of 36. We denote this by a little n. What we're going to do is go to cell C8. We're going to give it a title now. And what we'll call this is sample size, and then again we have a little n. The next step is to calculate the standard error of the mean, which is abbreviated as a capital SEM. As you recall, the standard error of the mean is equal to the population standard deviation and then divided by the square root of the sample size. We will program a formula into Excel that we will perform for us to calculate this. The first thing we're going to do is select cell E10. So here is E10. And we're going to put in the following formula in Excel. Again, we use the equal sign. And this time we're going to go and say, E5, which is the 16, divided by SQRT, parentheses, E. Oops. Sorry, I forgot to put in a parentheses, E8, parentheses. Now, this is what we're looking at for the standard error of mean. We want to give this a title, and the title, of course, is going to be the standard error of mean, which we abbreviate as a capital SEM. Oops, I have to capital it on. All right. We are now ready to calculate the z-test statistic. You may recall the z-test statistics is equal to the sample mean minus the population mean given the null hypothesis and then divided by the standard error of mean. I will now enter the formula into Excel to perform this calculation for you to save. Again, I'm going to go to cell E13 to enter the following formula. We're going to put equals, and then we're going to put a parentheses, and then we're going to highlight E1 and minus E3. We'll close the parentheses, but now we have to divide it by E10. And then hit return. As you can see, the computed z-test statistics is 0.47917, but we'll say it's negative 0.48. We have to give this a title again, and of course the title is going to be the z-test statistic. Now you can see we have our sample mean, we have our population mean, we have our population standard deviation, we have our sample size, we have our standard error of mean, and we have the z-test statistic. We now have completed step 3, and we are ready for step 4. In step 4, we need to determine the critical value associated with the significance level of the test. As you may recall, that this example is a left tail test with a significance level alpha of 0.05. Since this is a left tail test, we need to determine a single critical value which separates the bottom 5% of the standard normal distribution with the remainder of this distribution. We can use a built-in Excel function to do this for us. First, we are going to type in our alpha or significance level value into the cell E15. So let's go to E15. And we already determined that our alpha is going to be 0.05. Okay. And the alpha or significance level. So there's the title of our significance level. And also now we have the alpha value of 0.05. To get the critical value, we will use the standard normal inverse function found in Excel. First, you go to cell E17. Here we are at E17. And we're going to type in the following Excel function. Again, we start with the equal sign, and now we're going to do norm NIV with the parentheses, and we want it for the significance level, close parentheses, and enter. So when we typed in this formula, what we have is the norm. The norm means the normal distribution. The S means the standard normal distribution. And the INV means that we are taking the probability value for the standard normal distribution and calculating it corresponding Z value. The reason why I point this out is because there are several functions related to the normal distribution in Excel, and I want to make sure you use the correct one. In cell C15, we're going to type the title now. The title in this case is going to be the critical value negative Z. But what we have to do here is make this a subscript C. Let me see. Just for lack of time, I will keep that. As you can see, the critical corresponding to 5% in the left tail test is a Z score of about negative